Every modern city stands on a material so common that most people never question it. Concrete surrounds our lives from the moment we wake up until the moment we go to sleep. But hidden inside this grey material is an enormous climate problem. If the cement industry were a country, it would rank among the world's largest carbon emitters. And that reality has forced engineers to rethink one of humanity's oldest construction materials. The answer may be something called low-carbon concrete, a technology that could help build cities while producing far less pollution. And its story begins long before modern skyscrapers existed. To understand the breakthrough, we first need to understand the problem. Because the biggest challenge is hiding in plain sight. Concrete itself is not the main culprit. The real issue comes from cement, the binding ingredient inside concrete. Producing cement requires heating limestone to extremely high temperatures. Those temperatures demand enormous amounts of energy. Even worse, the chemical reaction itself releases carbon dioxide. That means emissions come from both fuel and chemistry. The world produces billions of tons of concrete every year. As cities grow, demand continues to rise. For decades, the industry seemed trapped by its own success. Then, researchers began searching for a different formula. Low-carbon concrete is not a single invention. It is a family of technologies designed to reduce emissions. One approach reduces the amount of cement used in each mix. Another replaces part of the cement with industrial byproducts. Materials that were once considered waste suddenly become valuable resources. Some companies are developing entirely new binders. Others inject captured carbon dioxide directly into fresh concrete. Surprisingly, that carbon can become permanently trapped. In some cases, the process can even strengthen the material. What once sounded impossible is already happening on construction sites. Traditional concrete relies heavily on Portland cement. Low-carbon versions reduce dependence on that ingredient. Engineers carefully balance strength, durability, and sustainability. Every adjustment affects how the material behaves over decades. Some mixers use supplementary cementitious materials. Others rely on geopolymers formed through different chemical reactions. Carbon curing systems add another layer of innovation. Instead of releasing carbon, parts of the process can absorb it. The result is a smaller environmental footprint and potentially a new standard for future construction. Low-carbon concrete is already appearing in roads. It is being tested in bridges. It is entering commercial buildings. And some governments are encouraging its adoption. Major infrastructure projects can influence entire supply chains. That creates demand for cleaner materials at scale. Investors have noticed the opportunity. Startups and established companies are racing to improve performance. The competition is accelerating innovation, and the pace of change is increasing every year. Yet, the transition is not simple. Construction industries are naturally cautious. Buildings must remain safe for generations. New materials require extensive testing and certification. Supply chains can also limit adoption. Some alternative ingredients are not available everywhere. Costs can vary depending on location and scale. Standards must evolve alongside innovation. No single solution can eliminate emissions overnight. But every percentage reduction matters. Humanity is expected to build more infrastructure in coming decades. That means billions of tons of materials will still be needed. The question is how those materials will be produced. Low-carbon concrete offers one of the most practical opportunities. It does not require abandoning modern civilization. Instead, it improves a material already used everywhere. That makes the potential impact enormous. Small changes multiplied across the world become transformative. And that is why engineers are paying close attention. The future may depend on innovations hidden inside ordinary materials. At first glance, concrete looks like one of the least exciting technologies on Earth. Yet it quietly shapes economies, cities, and daily life. The challenge was never whether we needed concrete. The challenge was finding a cleaner way to make it. Low-carbon concrete represents one of the strongest answers so far. Its success will depend on engineering, economics, and political will. The next generation of cities may be built differently because of it, and future generations may never notice the change. They will simply inherit cleaner infrastructure beneath their feet. The next time you see a block of concrete, you may be looking at one of the most important climate technologies of the century.